So we are the Slit Lamp group, and just for introductions, my name is Rachel Walker, and I'm from the Department of Bioengineering.
I'm Gina Taylor, and I'm with Art and Design, Industrial Design.
I'm Ziying, and I'm from ISC department.
So we've been working with Dr. Sikorsky over at Caro, and he presented us with two problems initially that he's had with his patients. One is that for short and also larger people, it's very uncomfortable for them to sit in the slit lamp because there's not much space in the chest area. If they're shorter, then the table's really getting in their way. And then another problem he had was easy viewing. The only way to view images for him was just directly through the microscope, so you couldn't really show anyone else what he was seeing. But we decided to refine the scope and really focus on increasing the space between the chin rest and the chest to make it more comfortable for people of varying sizes. So a little bit of background, the slit lamp is used as a way to diagnose disease, fit contact lenses. What they do is they shine a very bright light into the eye. And so here you can kind of see this is where the light source is coming from. As it's reaching the eye, we'll then go through several reflections, refractions, and that will produce a slit image. So it allows the doctor to actually see to the back of the eye and in all sorts of different angles. As you can see from these pictures, the slit lamp has not changed much since it was first created in the 30s. Actually, the 1959 image is almost exactly what it is now still. So not much has been changed. It's been working. However, like I said, it's not comfortable for patients, and I doubt it was very comfortable back then either. So here's just another illustration of where the problem is really occurring in these areas. You're being crushed sometimes in there, and even though it's a short examination, it's still uncomfortable. These are some existing technologies that kind of spurred our ideas. So what you see right here is used in surgeries. It's definitely a more expensive machine, but it allows for, the overhead mechanism allows for it to rotate around so that it can really reach the individual. So we use this in one of our concepts. And then one of the reasons why we weren't really focusing on his problem with viewing is because they are now making attachments for your iPhones for digital cameras and projecting them onto other screens. So that's already kind of a problem that's being solved. Finally, we just have a few design parameters that we had to keep in mind. Most importantly was that the back focal distance, so this is the distance from your eyeball to the light, has to be within 90 to 120 millimeters. So the distance between the slit lamp couldn't really be changed. We also need to ensure that the head is level and stable for an examination, which usually is under 5 minutes. And the base adjustments will have an animation later. They do move in the X, Y, and Z directions, and that's what allows him to be able to get the different angles and really get in closer or farther away so that he can produce these slit images. The chin rest does expand for different head sizes, and then the slit width and the fixation lights kind of rotate around almost 180 degrees, so we had to ensure that there was still space for these components to continue moving like this.
So while we were brainstorming, we came up with a couple of ideas, and I apologize that you can't see the one on the left. I think it might be because the light's on. Push the green button?
Yeah.
So, well, you can't see it there. This is basically the same thing. Our first idea was to have all of the base components moved above so that we have pivots and movement all happening up above, and it would be connected electronically. And the doctor would use this kind of joystick, almost like a computer game, to move everything. And that would eliminate this entire table space, so the patient would have a lot of room for their body to fill in underneath their chin while their chin stays exactly where it needs to be. So those are just some kind of iterations. Would we have it connected to the table, or would we have it connected via an arm? So that was the first solution. Another solution we came up with is to change this current design to only have one leg but it still presents a problem with part of the body being interfered with. And then we'd seen some other designs where the chin rest maybe is set back, and Dr. Sapersky had an idea, why can't we move the chin rest to the patient? We weren't able to really make that one work, but we did kind of take this idea and expand it further so that the leg is attached on the side, so we kind of combined two ideas into one. Before we got going on that, we went to Dr. Sapersky's office, and we also went to Dr. Kessler's office and scanned their slit lamps so that we could have the kind of working model, if we want to call it that, just to base everything off when we were doing our CAD modeling. We used two different types of scanners and got really different results because of the material of the slit lamp. The Z scanner is the one that we have here in the engineering building. And the structure scanner is what we checked out from the art building, and it does it creates object files, but it takes images basically, so it doesn't give you the same quality of a mesh. So from those, we did some initial iterations with the mesh slit lamp here being suspended from above, and this is Jill. Gave her eyes, by the way. She has eyes this time. But so we came up with this idea of attaching the chin rest to the side and having an arm that comes and suspends it, and then the chin portion can move up and down. But this would eliminate all of this need for the table. That one didn't quite work as well as we wanted. We couldn't take it any further than just a conceptual model because we don't have the ability to redesign the slit lamp being suspended from above. There's a lot of parts that would go into that. So what we did was take another look at the base components. We modeled those in Fusion, and we made movements of those, which I'll show you in a minute. But just in eliminating the need for the feet of the chin rest and attaching it from the side and above, we were able to give some additional space here. As you can see maybe here that we cut the table back a little bit. So this was our final design, which we have 3D printed up in the front, where the chin rest attaches on the side and it comes from here and holds the patient's head. And those are the different parts of it, but they're all 3D printed, and it actually works. The chin rest will move up and down with the little turn knob mechanism. But the motion study,
Yeah. So, let me.
yeah, I don't know how to make it. Oh.
So if you look at the motion study, the base component can move left to right and front and back, and the one. The one here that attached to the microscope can rotate from -90 to 90 degrees, so you can so the doctor can see different side of the eyes, and then that's basically the X, Y, and Z movement. So about the stress analysis, the analysis we did last time, it ended up with a maximum displacement of like 8 centimeters, but we in order to change that, we just thicker the pole and then try to widen the connection, and then they both like reduce the stress that we apply. So we applied a vertical force of 100 newtons because the average weight of a human head is like 50 newton, and plus it has to hold the chin rest and the forehead. And we also have a 20 newton horizontal force because people might want to lean forward and might add force to the forehead. So, and the material is steel, and we make the base fixed, and it end up with a maximum displacement of 0.2 millimeters, which won't affect the eye test very much.
Looking back at our designs, we were really just making sure that the measurements and dimensions that we were using were appropriate, and so we looked at the 95th percentile taken, so this means that the maximum sizes of these measurements for about 95% of the people in the study were found here, and so we've got them for males and females. This would be the length of your head, which is useful for whenever we were wanting the chin rest to be adjustable. Also the width of the head. We've got the distance between your eyes. We also have the circumference of the chest and the shoulder distance. So using an equation for the circumference of an ellipse, we found that for males and females, what the approximate depth is of the chest. And then
so we also select the material for the forehead chin rest and also the pole that connect those two. We choose TPE, which is thermoplastic elastomer, and it is pretty lightweight, so it won't add on too much weight, too much stress on the standing that we design. And it is also water and chemical resistant, and also the material can be easily manufactured basically by the injection molding. And we use aluminum for the poles because it's also lightweight and a pretty strong material, and then it is also easy to mold. So in summary, our design, basically the most important part is we save the chest space to 69.3 millimeters, so it add more comfort for the patient, and we adjust the chin rest height so it can be moving up and down to for more comfort, and we choose the pole material to make it have low deformation, and that's pretty much it for our project.
We also changed the attachment to the U-beam instead of an I-beam just for aesthetics.
Yeah.
So it looks nicer. Yep. Okay.
Okay, good. So for the chin rest, how did you improve upon what already exists?
Yeah, we didn't put that in here. So the basic chin rest that comes with most slit lamps, as you can see, it's this really, most are plastic or some piece of metal with a plastic insert, and it's some radius of, I'm not sure where they came up with this number, but they're not very comfortable, and they're not very, I wouldn't consider them ergonomic. I mean, they serve a function, and that's basically what they do. That's all they do. Our chin rest, I don't think we have any pictures of it closer up. This is the best. We have several iterations of it. We kind of made it more sculptural, and it fits the chin a lot better. And I mean, if you wanted to try it out, we have several. The first iteration of it was shorter, basically the same size as what is currently available. But after testing it out, I kind of extended it a little bit and made the lip that comes up a little bit higher. And I mean, it's only a couple of millimeters of difference, but it makes a huge difference. And that's one of the benefits of using Fusion 360 for this project, was we used Sculpt for the chin rest because it made it very simple. But it's actually, to me, it's a little bit more ergonomic. I would rather have my chin rest than what I currently get at the optometrist.
Okay.
Yeah.
And where did you get that 69 millimeters
of space
Space
saved,
saved.
that's the
That's-
distance of what we've cut off of the table.
Yeah.
So compared to what we originally had from the scans that we had the table included in there. So whenever we cut off this portion, that's how much space we were able to cut it.
Okay. Anything else? Okay, very good. Very good.